All right, welcome. Okay, so we're going to learn about the secondary trigonometric function. So um, that's just a phrase I'm introducing, so that's not the official phrase, but it fits. So the language I'm using here is I'm going to say the primary trig functions. That's given by, let's say we have a point xy on the unit circle. Okay. So for the primary trig functions, we've already learned sine theta is y, cosine theta is x, and tan theta is y over x. Okay, now we also have cosecant, secant, and cotangent. Okay, so I'm going to put cosecant goes with sine, and that's the inverse of sine. Okay, or the reciprocal, sorry. Slight difference of wording. And it does make a difference, so it's the reciprocal of sine. Secant of theta is the reciprocal of cosine. Okay, and cotangent of theta is the reciprocal of tangent. Okay, which also one thing I want you to notice about tan theta and cosine theta is that tan theta, you could also write this as sine theta over cosine theta. And cotangent of theta, you can write that as cosine theta over sine theta. Okay, so let's get into a problem. Okay. So we're given this point, -2/7, 3√5/7, and we're going to find secant of t, cosecant of t, and cotangent of t. Okay. So, draw the picture. Okay, so this is going to be in the second quadrant. Okay. Say it's about here, looks to be. Okay. I'm not going to check that it's on the unit circle. I'm going to trust that it is. Okay, actually I'm going to check. I can't let it go. So let's check x squared plus y squared equals 1. So we're going to have 4/49 plus, that's going to be what? 9 times 5, 45 over 49 equals 1. Check. Okay, this works. It is on the unit circle. So secant of t. Remember, secant of t is the reciprocal of cosine. Okay, so that's 1/x, which is going to be -7/2. Cosecant of t, that's the reciprocal of sine. So that's 1/y, 7/3√5. Oh, let me write that better. Okay, we have a problem here. Uh-oh, we have to rationalize this. Okay, let me write it a little bigger or zoom in. Okay, MyLabs Plus does not like having, sorry about that, does not like having square roots in the denominator. So what we're going to have to do, we're going to have to multiply on the numerator and denominator by square root of 5, so that we'll have our square roots in the denominator. Okay? So 7 over root 5 over 3 times root 5 times root 5. Well, remember, root 5 times root 5 is what? That's right, is 15. I'm sorry, 5 times 3 is 15. Okay, so ah, 7 root 5 over 15 is the proper answer. Okay, let's go to cotangent of t. So cotangent is, remember, that's going to be, let me write it here, that's the inverse of tangent. So it's going to be x over y. Okay. Okay, so it's going to be negative 2/7 divided by 3 root 5 over 7. Okay, so then I'm going to go ahead and I'm going to multiply, or I'm going to do what I normally do when I divide by fractions. I'm going to flip the second and multiply. Okay, my 7's cancel. Okay, so I get negative 2 over 3 root 5. Again, I'm going to have to do this rationalization. So I'm going to have to multiply by square root of 5 over square root of 5 on the numerator and denominator. And I get negative 2 root 5 over 15. Okay, so just to sort of be clear, secant here was negative 7 over 2. Cosecant, the answer you're going to have to plug in is 7 root 5 over 15. And cotangent, let me put this all in one. Highlight it. That'll be better. Cotangent was negative 2 root 15, or root 5 over 15. Okay. All right, let's see what else we got here. Okay, so the next thing we're going to do, we're going to talk about what most students think of as the unit circle, but it's not really quite the unit circle. It's not really quite what I mean. So let's go ahead and let's copy this. Let's zoom in a little bit on here. Okay. Let me fill that back in. Okay. So what we're going to do is we're going to fill out some known values on this. Okay. So first known value. So we have in each quadrant, we have 3 angles. Actually, we could just technically say 5, because this angle here, okay, and we're going to do this in radians for the most part, but I will talk about the degrees. This angle here is 0 radians and 0 degrees, and the point that corresponds with it is the point 0, 1. That's definitely wrong. 1, 0. Okay, so for example, from here we get that the cosine of 0 equals 1 and the sine of 0 equals 0. I don't have the degrees on there, so I'm doing that. That's radians. Okay, but it is same as true for the degrees. Let me just that little bit. Oh, that's going to look terrible, but oh well. Okay, it's been repaired. Okay. The next angle that we have is 30 degrees, or we might say pi over 6. Let me put the angle in. So pi over 6, or 30 degrees. Okay, the point is going to be square root of 3 over 2, 1/2. Okay, so again, cosine of pi over 6 is square root of 3 over 2. Sine of pi over 6 is 1/2. The next angle, let me write it in here no. So the next angle is going to be pi over 4, or 45 degrees. Okay, and the point is square root of 2 over 2, square root of 2 over 2. Okay. The next one, the next angle is pi over 3, or 30 degrees. And the point is actually, you switch around. So it's going to be 1/2 square root of 3 over 2. And then up here, this angle is pi over 2, 90 degrees, and the point is going to be 0, 1. Okay, so there's a couple things I want you to notice here. Okay. For example, 1 equals square root of 4 over 2, and 0 equals square root of 0 over 2. So if you look at this, you can see we're counting down in x while we're counting up in y. Take a look. 4, 3, 2, 1, 0. 0, 1, 2, 3, 4. Okay? So that's a nice, easy trick to remember the basic ones. Okay? Now, we can extend this. We actually extend it in much the same way. So once we have that first quadrant, we really don't have to do much for the rest. So we have these 3 angles. Okay, so now this angle here is, well, it's 180 minus 30. So 150 degrees. We could also think of it as pi minus pi over 6, which you'll get better at doing fractions over time. That's going to be 5 pi over 6. So 5 pi over 6, or 150 degrees. Okay. And the point on the graph is going to be, now it's almost exactly the same as this point, except for now it's going to have a negative x coordinate. So the point on the graph here is going to be negative square root of 3 over 2, 1/2. Okay. This point here, that angle, well, it's going to be pi minus pi over 4. Okay, so remember, halfway around this is pi. Okay, and you go back the pi over 4. So it's going to be 3 pi over 4. Or 135 degrees. Okay, and the point is going to be negative square root of 2 over 2, square root of 2 over 2. Okay. This angle, that's going to be pi minus pi over 3. That's going to be 2 pi over 3 as the angle. Or, let's see. This one was wrong. That should have been 60. Sorry about that. Just noticed. And the reason I noticed is because I was like, okay, I'm just going to do pi over 3 times 2 is 120. Okay. And the point, let me move this a little out of the way. The point on this circle is going to be negative 1/2 square root of 3 over 2. Okay. This angle over here, I've already mentioned it. It's 180 degrees or pi. Okay, and of course the point is going to be negative 1, 0. Okay. All right, we're going to keep going. Okay, I'm going to go much faster now. Okay. I have 3 more angles in there. Okay. Doing the same sort of thing. This one is 7 pi over 6, or 180 plus 30, 210 degrees. I don't even remember the degrees anymore. I just use the radians all the time. Okay, and the point sort of corresponds with this one, except for now here, both the coordinates are negative. So cheating a little bit. Okay. Similarly, that's going to happen here. Running out of space, but oh well, we'll do it inside here. Okay, let me go ahead and write out what the angles are. So this angle is 180 plus 45. So that's going to be 225 degrees. Or pi plus pi over 4 is 5 pi over 4. Okay. This angle down here is pi plus 60, pi plus pi over 3. So it's going to be, what, 4 pi over 3. Make sure, yep, 4 pi over 3. Or 180 plus 60 degrees, 240 degrees. Okay. Okay. Down here, we're going to get, let me put that in there. Down here, this is going to be 270 degrees or 3 pi over 2. Running out of space. Okay. And the point is, of course, 0, negative 1. Okay. Same thing here. So we're going to have the same sort of points. Okay, so this point now, the only thing here is that the x-coordinate is actually positive while the y-coordinate is negative. Okay, now what's this angle? I'm going to say this because this angle is 0 or 0 degrees, but it's also 360 or 2 pi. Okay, so this one goes to 2 pi, 360 degrees. That's one full way around. Okay, so I'm going to think in terms of 2 pi minus pi over 3 is 5 pi over 3. Okay, 5 pi over 3, or I could also think in terms of 360 minus 60 degrees is 300 degrees. Okay, doesn't like the edges there. Okay, the next point over here, well, I'm going to copy it from up here. Okay, again, the y-coordinate here is negative. Okay, what is the angle? 2 pi minus pi over 4 is 7 pi over 4. 360 minus 445 degrees is 315 degrees. Okay, finally, the last point here. Square root of 3 over 2, 1/2. Let me erase that little extra that got in there. Okay, what is the angle? Oh, I should have a negative somewhere. Let's put that here. Okay, and what is the angle? The angle 360 degrees minus 30 is 330 degrees. Or 2 pi minus pi over 6 is 11 pi over 6. Okay. All right, so this is what traditionally a lot of people consider as the unit circle. Okay, so really the unit circle is just a circle of radius 1 centered at the origin. But when people talk about the unit circle in pre-calculus, this is what they're talking about. Okay, and traditionally this is something that's memorized. Okay, all right, I'll see you guys in the next video.